Hi, my name's Taylor Mance. This is my balloon geometry presentation for Chem 121 at CSU Global. All right, let's get into it. So today I'm going to be talking about different types of molecular geometries using the VSEPR model, or the valence shell electron pair repulsion. That's what that stands for. So using that model, you can predict the type of structure of nearly any molecule. And so there's 5 different types. So I'm going to talk about linear shape, trigonal planar shape, tetrahedral, trigonal bipyramidal, and octahedral. Okay, so I constructed a balloon molecule for each of these, so I'll kind of go through that and walk you through it. To start, this is the linear geometry. It has a central atom with 2 pairs of bonding electrons. It has 2 electron domains. It has bond angles of 180 degrees, so it's flat, like a straight line. There are 0 lone pairs, and the example I chose was carbon dioxide. So if you take a look here, I have 2 balloons bonded in the center here. I taped them together. Another way to look at it, obviously this is the 3D version. 2D version is down here. So you have the central atom with 2 pairs of bonding electrons. So this would be CO2. Okay, next up I have trigonal planar shape. This one has a central atom with 3 pairs of bonding electrons. It has 3 electron domains, 120 degree bond angles, 0 lone pairs, and the example I chose is nitrate. So here we would have the central atom being nitrogen with 3 oxygen molecules around, just like it's shown here in the 2D model. Unfortunately, I don't have all the same colored balloons, so in this case we would have them be all red, but I was using them for a different model, so that is nitrate right there. Okay, next up we have tetrahedral. This has a central atom with 4 pairs of bonding electrons. It has 4 electron domains. It has 109 degree bond angles, 0 lone pairs, and the example I chose was methane, or CH4. So if you see over here on the side, it's a little bit more 3D, and that's why I actually liked doing this exercise with the balloons. It just was, you're able to visualize it a little bit better than on the 2D version down here. Again, you would have in the center here the carbon atom with 4 hydrogens surrounding that. Oops, okay. All right, and next up is trigonal bipyramidal. This has a central atom with 5 pairs of bonding electrons. It has 5 electron domains, 3 pairs in a plane forming 120 degree angles, and the remaining 2 pairs form 90 degree angles. There are 3 lone pairs, and my example that I chose was phosphorus pentafluoride, or PF5. Did my best with this balloon geometry. It was really hard to get them to stick together. I think maybe string would have been easier, but I didn't have any. So again, you'd have the center be phosphorus, and then you'd have all the other remaining outer shell or outer bonding electrons here. Again, ideally they'd all be the same color, but I didn't have that luxury, so I have 2 of these outstanding yellow ones. All right. And then finally we have octahedral. So this one has a central atom with 6 pairs of bonding electrons. It has 6 electron domains and 90 degree bond angles. There are 0 lone pairs, and the example I chose was sulfur hexafluoride, or SF6. So again, I tried my best with this one. It's hard. It probably was easier if I would have held them together and then took a photo, because I could have had, this bond angle here so that they're all 90 degrees. It was kind of harder to do with the balloons, but I did my best, and I took multiple kind of angles of the picture. But ideally there's one balloon underneath here that's holding it all up. I also could have just moved this balloon down a little bit more, and then we would have had those 90 degree angles. Again, here you would have had sulfur on the inside as the central atom, with the surrounding 6 balloons. All right, and those are my references. Thanks so much.